Hey everybody, we are going to look at our AKS portfolio today for 6C. It says I can analyze and interpret data from a solubility curve to determine the effect of temperature on solubility. So I first want to remind you that solubility is just the ability for a substance to dissolve. We've been talking a lot about solutions. So we're going to go and look at your AKS portfolio. You should see this image on your sheet for 6C. And let me explain a little bit of it to you. So first, let's remember, in order to make a solution, we have to put a solute into a solvent and dissolve it, and then it becomes a solution. We can do that in a variety of ways. We can stir it, we can heat it up, we can mix it, we can grind it and increase the surface area to make it dissolve faster. But the proportion of solute to solvent is its solubility, okay, the amount that's actually being dissolved. So if you're looking at this graph, you're seeing that our x-axis is temperature. So we have temperature increasing, and then we have the solute in grams per 100 grams of water, okay? So for every 1 gram, we're stirring it into 100 grams of water, and this is giving us our y-axis. There's one line graphed on this, and this is the dotted line here. So we have one unknown substance. It's not telling us what it is, okay? And it's graphed here, and it's saying that this line is saturated. So what that means is if I have a certain amount of solvent and I add my solute to my solvent and I stir it up and it's dissolved, that is the maximum amount of solute that will dissolve in that amount of solvent. Okay, that's called saturated, the maximum amount of solute that can be dissolved in that amount of solvent. So if I have less than that, if I have 1 scoop less, 1 tablespoon less, whatever it is, if I just have less of that maximum amount, it would be considered unsaturated. I can still add more solute and it would still dissolve. So if I have under that amount, which is right here in this pink shaded area, depending on the temperature, notice as temperature changes, that amount's going to change, okay? So as temperature increases, I can dissolve more solute into my solvent. Notice how much bigger space this is right here. Or over here at a lower temperature, we don't have a whole lot that can be dissolved, okay? Now on top of the line is supersaturated. That is where I have put in too much solute into my solvent, and now it's not dissolving. It's just settling at the bottom, and I can see this thick, chunky layer at the bottom, and no matter how much I stir it, it's just settling back to the bottom. It's staying in solid form. It's not dissolving thoroughly at all, okay? So that's just the extra portion of my solute that will not dissolve. So you can see all of this blue section is my supersaturated section. So now I have put way too much solute in and it's collecting at the bottom in solid chunks, okay? So unsaturated, I can still dissolve more solute. Saturated line, just look at this for a second, it's just one line. That's the only spot in the entire graph where I have the perfect amount of solute that can dissolve into my solvent. If I add more, I become super saturated. It's too much solute into my solvent. Okay, I've added too much. Now it collects at the bottom of my container. Okay, so let's go ahead and look at this next portion. This is a big solubility curve. There are a lot of lines going on in this graph, and I don't want you to get confused. Every question is just going to refer to one of those lines at a time, so please do not think that you need to look at every line for every question. That's just not how it is. We're going to look at one line at a time, and we're going to ignore all of the rest that's going on, okay? So let's go ahead and look at this. It says, what is the solubility of NH4Cl at 90 degrees? And let's see if I can just flip it over here for you guys. Hopefully you guys can see this behind my head a little bit, the x-axis down here. So the very first thing we want to do is we want to find NH4Cl. And notice it is right here, okay? So this is the only line on the graph that we're going to focus on. Please ignore all the other lines that are happening. Just pretend they're not there for a minute. So it says, what's the solubility of NH4Cl at 90 degrees Celsius? Well, our temperature is the x-axis. So if I go to 90 degrees and I go straight up until I intersect with NH4Cl, it's right here, okay? So if I go straight over now, I can see that that is 70 grams of solute, okay? So 70 grams can dissolve at 90 degrees. Do you guys see how I did that? I go straight up for 90 degrees until I hit that line, and then I go straight over to see what it is on my y-axis, and it's 70 grams. So 70 grams can dissolve at 90 degrees because this line, remember, means saturated. So that is the maximum amount of solute that can dissolve in water at 90 degrees Celsius for NH4Cl. Notice each line is different because each line is a different substance. The different substances are going to have different solubilities. They're going to have different amounts that can dissolve at different temperatures. And that's what this graph is showing us, okay? So number 2, at 30 degrees Celsius, 60 grams of potassium chloride is dissolved in 100 grams of water. So right here, this 100 grams of water, do not look for this over here, you guys. What this is saying is this part right here, per 100 grams of water. Do you see that? So it's just saying what we already know about the y-axis. So please don't look for it actually in the numbers, okay? That's just a fact about the graph only. So we're going to first start looking for potassium chloride. And if you guys remember, potassium is K, chlorine is Cl. So potassium chloride is right here, this line, and it's saying at 30 degrees, and I have 60 grams. Is it supersaturated, unsaturated, or supersaturated? So I'm going to go and I'm going to look, well, 30 degrees is right here, and I'm going to go all the way up to 60 grams, and this is my intersection for 60 grams and 30 degrees is right here. My line for potassium chloride is way down here. Do you guys see that? So I am definitely above the line. In fact, anywhere over here, right? Because there's a line, anywhere over here would be above the line. And I am definitely above the line right here. So this is super saturated, okay? Number 3, as temperature increases, what happens to solubility? I can use the graph for this, but I don't necessarily have to. I can just think about it, okay? So as I'm increasing temperature, my solubility, notice my all of my lines are going upwards with the exception of one. It's because I'm increasing my solubility. More of my solute is being able to dissolve into my solvent. So increasing would be the correct answer. So then let's look at number 4. Why does pneumonia have a negative slope? Here's the negative slope, NH3, which is ammonia. So why does ammonia have a negative slope? This is kind of a weird one, okay? Ammonia, it is a gas. It works very differently than the other substances when it's dissolving. So it actually has the opposite solubility from the rest of the substances on these graphs. A normal one would increase solubility as temperatures increase, excuse me. This one does the opposite. Okay, so as the temperature decreases, it is also going to it's going to increase, if you guys see that. So as temperature goes down, it goes up. As temperature goes up, it goes down, which is totally reversed from the rest. Okay, this is not a common thing. That's why I'm pointing it out to you. And then number 5, at 50 degrees Celsius, 10 grams of KClO3 is dissolved in 100 grams of water. How much more solute would dissolve at that temperature? So if we're looking at this, the very first thing we want to see is the KClO3. So if I look for which one that is, it's right here. You guys can see that behind my face over here. And remember, the 100 grams of water is referring to your y-axis, so please don't look for it on the graph, okay? We are going to be looking for 50 degrees, 10 grams. So 50 degrees, 10 grams is where they intersect right here. See the 10 grams go all the way to 50. My KClO3, the line is all the way right here. So if I'm at 10 grams, how much more can dissolve? Right now, I'm in the unsaturated section, right? Because I'm underneath the line. So I'm unsaturated. I know I can go ahead and dissolve more, and I can dissolve more up into my saturated point, which is where the line is. So if I'm at 10, I can go all the way up to the line, which is at 20. Do you guys see that? If I go straight across, is that 20 grams? So I can dissolve 10 more grams of KClO3, okay, in order for it to be perfectly saturated. I do want to show you guys one more thing. Okay, so just really quick simulation. We have drink mix, kind of like Kool-Aid, okay? It's in a solid form. We have a container of some water. I've hooked up a concentration meter, so it's going to show you how concentrated this solution will become, okay? So I'm going to shake a little bit of the Kool-Aid powder in. Notice my concentration is increasing, right? And I can tell, well, the water went from clear to a pink shade, right? As we are increasing concentration. Right now, I can call this solution diluted because there's a whole lot of solvent in the water, right? The solvent is water, and my solute is the drink mix that I'm putting in here, like my Kool-Aid powder. And I just have a tiny bit in there. So it's very diluted. As I increase the amount of solute I put in it, notice my concentration's going up. So I'm getting more and more concentrated. I'm getting a deeper shade of red. I can see that, right? There's going to come a point, right now it's undersaturated. I can continue to add. It can continue to dissolve, okay? So right now I'm unsaturated. There's going to come a point where I'm perfectly saturated and I can't have any more. We passed it. Did you guys see that? There was a point where if I stopped shaking, it would have been the perfect amount to be dissolved. But as soon as you add a little bit more, now we're past that and we're super saturated. See, it's telling me, hey, you're saturated. You're done. Stop adding. But do you see it's starting to collect on the bottom here? These solid chunks are the super saturated portion, okay? So if I keep adding and keep adding, notice they're still collecting. They're not going to dissolve anymore. I've dissolved all I could when it was saturated perfectly. Above that is super saturated, okay? Now I do want to show you something. Let me see. We're going to remove it. If I just add a little bit, this is just unsaturated. I want to take this unsaturated and I want to show you my concentration level right now, 1.337. If I add more solvent, so I'm going to add more water, notice that number goes down. I'm making my solution more and more diluted, okay? If I want to increase the concentration, make it more concentrated, I add more Kool-Aid powder, and then I can reach that perfect spot of saturation where I cannot dissolve anymore. Once that happens, I will collect more and more on the bottom, and it will become super saturated with the chunks at the bottom. I have a lot of water in here, so there we go. It just happened. So I hit saturation. Now I've progressed on to super saturation with the chunks at the bottom portion here. All right, guys, thanks.